The link has also been posted to Discord, so if you missed it, you can get it from there. We actually have a bit less time. I hope more time, but we have to close at 5:45. That's like 35 minutes. So I'll probably not wait too much at places where I would like you to do things, but let's see how it goes. Okay, so this slide is about how do we interact with a substrate blockchain. Actually, before we start the slide, do one more thing. Uh, these commands you will find in the HackMD link as well. But clone Polkadot SDK and try to do the compilation because it takes a long time. And while you're compiling, we can cover some theory part. Everyone got the link, right? HackMD is open for everyone. Anyone who's still waiting? Okay, so whenever, just keep doing this. Do the compilation process so you save the time later. I'll start moving and go with the lecture. Okay, does anybody want to answer? So when we say I interact with a blockchain or a DApp interacts with a blockchain, what really happens? How do you interact with the blockchain? Can you expand a bit more? Like what are RPC nodes?
All right, so get a little bit more simpler here. REST API calls, more or less, for the nodes. REST being the way that we basically call any sort of network service. So it'd be kind of a natural extension to more or less just use something like a REST API to interact with the substrate blockchain for any sort of like external application, such as a mobile application or any sort of like other application that's needed for that. There's also built-in smart contracts. More or less, you can actually go ahead and interact with that using various libraries to actually more or less deploy your smart contract and the various other applications more or less for smart contract interaction on the blockchain, for instance. This is how it's usually done with majority of other blockchain networks, more or less. So.
Yeah, thank you. Yeah, so you said REST, it's a little bit different. I mean, REST is like HTTP and get, set, all those calls, what I'm saying. Get, put, all those are HTTP methods that generally is used in REST. RPC kind of stands for remote procedure call, and you can think of it as you're trying to execute a function that is on a remote computer. And how you do it, that's what we'll cover. That is what basically JSON RPC protocol is in a nutshell. So to interact with a blockchain, first you need to find a node that publicly exposes the RPC interface that it has. All substrate nodes have like a inbuilt RPC server, but you can choose not to expose it. So you might have seen like, I don't know, on finality RPC node or something on Polkadot.js, you choose which link, or on MetaMask, you can change the network. It actually links to some RPC node. You found a node, or you can actually run your own node and you can interact directly locally with that. This represents the exact same thing what I said. So any substrate node has this server layer that, in this context now, it's a server, and the client is any dApp, any wallet, block explorer. It interacts with the chain by calling this JSON RPC server. So JSON RPC is a remote procedure call protocol encoded in JSON. We represent the function call that we are doing, we pass the function name, we pass the parameters in a JSON format. That's basically all it is. It's similar like XML RPC. XML was used extensively, I think, before. Yeah. So let's take an example. Let's imagine a remote computer. It could be a blockchain, it could be something else. It exposes a function subtract, and it takes two params, minuend and subtrahend, and you pass this. Anytime you want to get a response, you pass some ID just to make sure you got the right result back. You pass it to a server. If server processes it correctly, you get back a response that gives you your result. Simple enough, right? And this is what Substrate JSON RPC does as well. It's entirely transport agnostic, so you can use a WebSocket, HTTP. These are supported by Substrate today. I don't know if there are more protocols, but it doesn't matter. JSON RPC is something on top of these transport layer. Okay. So the RPC methods any substrate node exposes are kind of the pattern scope and the method. Scope is something, so you categorize like what is the scope of this function. We'll see example what are scopes and the actual function name. One example is, so whenever you have to interact with the substrate chain, you can actually call this RPC methods function, and here RPC is the scope and method is like it tells you the list of methods that a substrate node exposes. So what are these scopes? There is a scope called author, and again it has multiple methods that it supports. Author is used mostly to submit something to the chain. Generally it's an extrinsic, or you can think of it as a transaction. You will see the difference between extrinsic and transaction, but for now you can think of it as just a transaction. There's a chain scope to get information about the blockchain, what is the block, current block, what is the finalized block, what is the block number, head, whatever about the blockchain you get from the chain scope. There is a state scope which helps you read the storage value directly from the blockchain state. So you'd say, at this block, this storage key, what is the value? There's a system scope. It gives you like general information about the chain. Things like metadata that we talked about, that probably is part of state. Actually, there is a link I can show so I don't say something wrong. Oh, no. Sorry, give me a second. So there's a link in the notes that you will get with the slide that has all the scopes defined, and you can see chain. Chain has get block hash, get finalized head. Then there is system, and system has things like peers, chain type, chain. Again, we will see all that again, but it's related to the client, the node part that Kian explained in the previous lecture. I have to just. Okay. With that intro done, has people did you finish the compilation? Is it compiled for you? Can you raise hands, whoever has the compilation done?
It's still downloaded.
Okay. Okay. In interest of time, I'll try to just go forward a bit, but you could try everything I do here by yourself later. And if you run into problem, we are all here till at least this whole week. So yeah, hopefully it makes sense even just by watching. So it's a simple use case. We want to transfer some tokens from Alice to Bob. Alice and Bob are like default accounts in any substrate chain. Whenever you start a dev chain, it actually comes with some default accounts, and it has already minted some balances. And we'll just take that just for this to be simple. Also, at some points, we will cheat a bit. So we need to calculate like sometimes the encoded extrinsic, the storage keys, and we will take help from this Polkadot.js app to do those things. You will learn actually how to encode your own extrinsic in the next assignment. And hopefully by end of the frame, the hacks that we do here, you will learn more about it and you will know what exactly to do to even do everything by hand here. Okay, if you have already got your node to be compiled, you could actually run this command and look at all the commands that it supports. I mean, we don't have too much time, so I'm going to skip, but it's a good exercise just to look at all the subcommands that this substrate CLI exposes. So I'll just go on with the actual thing that we have to do. If you have your node compiled, run this command and that will start up a chain locally on your system with something called chain type dev, which means you will get these pre-funded accounts on your dev chain, and minus minus temp, which hopefully you figure out from the last command what it does. So it's okay, it's okay. So the question was, what does this minimal node include? It includes the minimal thing you need to run a blockchain. It's like a node template in a way. I can't tell you too much because you have not covered frame, but once you cover frame, this code is in Substrate SDK, you will be able to look by yourself what components it has. So for now, just take it that it's a minimal things, like balance and...
Yeah, the reason I ask you because Polkadot SDK has so many projects within it, right? So I know it is, you made minimal node because compiling the whole thing may take more time than the, using this flag. So just wanted to understand like what it adds and what it doesn't add.
Yeah, I mean, once you understand frame, again, you can actually look by yourself in the runtime code and see what modules or palettes, we call it, are included in that runtime.
All right, thank you.
Has anybody got their chain running? At least few? Does anybody want me to wait?
I'm still downloading, net is slow.
Do you want me to wait?
He has it running.
Okay, perfect. Okay, let's do the first thing. So the hackmd that you got, it has a storage key for Alice and Bob. There is a RPC command called state_get storage. Again, all these are there in the hackmd. Pass the param as the storage key, and you will get some value. And I said it's already pre-funded, so you should hopefully get some value, not empty value. Just to explain, the storage keys are where the balance of Alice and Bob is stored, but it's like some complex structure. If anybody is done, just tell me what you... Okay.
So what slide we have?
Okay. You mean this, right? It's too bright. So you have these storage keys here. You can use this to query your local chain and get... It should be on Discord.
Please use the mics. Who has a question? Use the mic.
So if anybody is done, can they tell me what they get? What value do they get? So I gave a hackmd link in the beginning. Did you get that? In that there is a set of commands that you get, and find the get storage and the storage key of the balance of LS. You don't have the library installed. You might have to install WSCAT. So WSCAT is a WebSocket CLI tool, and yeah. To install. Can you just do so? I think it's not that. We try to follow this, but hopefully we can sort it out. These are CLI commands, and there is RPC commands, and there should be get storage. So I will do it for you, and so hopefully you see what's happening. Maybe the first one I do with you. So I copy the get storage command from the hackmd link here. You need to have WSCat installed. JQ is not important. You can remove that part. It's just to make it nice, pass the JSON. But WSCat you will need. Unfortunately, if you don't have, you probably, okay, great, perfect. So I will do it with you.
Yes. Hello. What is supposed to be the output of that command?
You tell
Because,
me.
No, I have a very long list of methods and one ID, the ID 42.
What do you get, sorry?
A list of methods. The
Not-
result
so
is.
I think you did a RPC underscore methods.
Yes,
So when you do RPC methods, it returns all the methods that your substrate node supports.
So it's
Uh,
perfect.
Yeah, it's perfect. So you get that and you figure out what functions I can use to interact with my blockchain,
Ah,
right? And then I want to check the balance of LS. And so I need to get the storage key. And now we are cheating a bit, and I'm just telling you this is where the storage key is stored. You will learn later in frame how these storage keys are derived. But for now, you just like trust me that the balance is stored at that storage key, and try to query the storage, the balance of LS.
okay.
I'll show you how to do it with me. Give me a second. It's a bit difficult, but I copy this command. I run this. I get the storage key of LS. And I pass it as a param. Has anybody already done this? What do you get? Okay, so what you get is a scale encoded data. Oh. Did I zoom in too much? I'm not running the node. Stupid. I'm not running the node, sorry. So you get this weird rubbish data that you see. This is the scale encoded data. And we need to figure out how to decode this, right? How do you know how to decode this? Correct. So we need the type info. How do we get the type info? Can someone pass mic at the back? Who has the mic? There, back.
Sorry.
Yeah. Type info. Okay, there are so many places to get type info, but the one place is metadata of the chain, the metadata of the chain.
Can you repeat that? Sorry.
There are many places to get the type info of the balances type. You can get it in the metadata, or also looking in the runtime.
Yeah, so it's correct. So we can get the type information using the metadata. If you see the RPC methods again, there is a function called state underscore get metadata. Can someone try to execute that and see what it returns? So we have 15 minutes and unfortunately we don't have too much time. So in interest of time, I will just, we can go over time, but I think they will close the door. Yeah, we are out of time. So I'll just do this for you. Hopefully just look at the screen. So I try to get the metadata. And what do I get? Another scale encoded metadata. Right? Doesn't make any sense. And this is where we will do a little bit of hack, because this, to decode this, you need to understand frame. You need to figure out how frame shares metadata. So it's very tricky. We are going to cheat a little bit here, and we will go to this amazing app that will be covered later for you. But I will show you some things around Polkadot.js. Hopefully you will get more, you will see more of it later in different lectures. So I want to see metadata, and I can use this to do the same exact RPC call that we did by ourselves, but it decodes and gives it to us. If somebody wants, oh, it's okay, I'm doing the wrong thing. I go to state, metadata, and the submit. And so now you get some type information here. Now it's really long, really long. Complete information about the chain. It has. I will show you a stripped off version. So this is the exact same thing I copied and put it in a link that again you can find in the HackMD. It's here, this one, in a new tab, and it contains, if you see, there are types, and it has like a lot of types and type IDs and stuff, and then it has something called palettes that you will cover in the frame. There is extrinsic. I have emptied it, but it's like huge long list of stuff. So it explains everything, like what storage types are there, how are they formed, what will the struct look like. So you can use metadata to derive all the types that you need to interact with the blockchain. And you do this in the beginning. So any dApp would get the metadata. I mean, if you have used substrate-based dApps, you would have seen like some pop-up saying update metadata. And this is what it is. If something changes, if you add a new extrinsic, then your metadata will be changed, right? And your dApp, to get that new information on the fly, it has to download the new metadata. Okay, and if you actually use this HackMD file, you could actually figure out how to get what is the type of this account info. And now I will share like a very condensed form. So you can use, so this is roughly the type. There is the storage 000 thing that you got. It's actually something like this, but there are more fields here that I have kind of exploited the scale properties to just ignore it because you don't need to know these values, but you need to know what is the balance free, and there is something else nonce that I will show you what it is. So if I now get the data again, this 00, bunch of zeros and other numbers, I get this. And what I do is, there is a scale decoder link that is shared in the HackMD. You open this, you use this to decode this. You paste the raw bytes that you got from your RPC. You tell what type it is. And the type, yeah, exactly. It's opaque and you have to give it a type so it knows what it is. And I give it a type and I get nonce is 0, balance free is 1000.
So it's like we first got the scale decoder, I mean raw bytes. Then we got the types, the one which you just showed, right? And now combining these two, we are coming out with
Exactly.
the output, right?
Exactly.
Okay.
If
That's
you
a lot of
have
process.
time later, what you can do actually, this is not really exact type. So if you see this ignore fields are actually 3 other fields. And you can use the metadata shared in the link, not the big one, but the small one. And you can actually derive the complete type of account info.
So you're saying you don't need the whole thing, but the small type.
No, what I'm saying is the actual metadata that you get is really big. And
Yeah.
I shared a link where there is a stripped metadata which has only details that you will need to derive type of the balance or the account info. Everything else is stripped off.
Okay. So that metadata you need to design like from this big one to derive a small one to get this.
Okay, maybe I confused you, but it's exactly same metadata that we got from the Polkadot JS app. I just, to make it easy to remove the data that we don't need,
Okay,
it's just
okay, okay.
same metadata, but just stripped off some details.
Yeah, understood. Thank you.
Practice, like there's, so the types are lost over RPC, right? Like because of the encoding. Is there like a SDK, something like
Yes.
Okay.
So no, you don't have to deal with this by yourself. You will have to deal with something like this for your next assignment. But eventually, once you learn Frame, once you something called Polkadot JS API that helps you do these things just with JavaScript code.
Okay. Are we expected to use this Polkadot JS hack on the assignment? No.
No, sorry, come again.
On the assignment, are we
For the
expected?
assignment, not this much. It's much easier, but still you have to deal with the RPC methods by yourself.
Yeah, but like specifically, are we supposed to use this tool?
No.
Okay.
You don't need
This,
to.
yeah, okay. Thanks.
So I mean, another way to do this is just writing a test case, right? Where you put the struct and you try to decode it, right? So actually, I have just 7 minutes left, and I kind of want to at least show you the whole thing. So I will just try to do this myself, but we have to do the assignment intro, right? Okay. Okay, so now we got the balance value, right? Correct screen is this. Now what? So now we want to, this we already done. We use this. Now we want to actually transfer some tokens from one account to another. In this case, we will do Alice to Bob. Again, we will take help of Polkadot JS to create the signed extrinsic that we will need to submit to the chain. What we do, we go to account. So this app actually, if you see, it shows Alice has 1000 balance. Exactly same thing that you saw when you decoded it. If you check Bob's balance, you will get the same thing. Now I will try to send from Ellis to, let's say, Bob, 100 tokens. And instead of using this to transfer, I just want to get the signed encoded extrinsic, so I can use RPC method to submit it. And this here shows the signed transaction. And you just copy this and you use another RPC method called author submit extrinsic. So we talked author scope is used to submit something to the chain. There is a function called submit extrinsic, and we will use this. So if we did it correctly, if we read the storage again, it should have changed. And I don't know, I don't remember the exact text, but it's the same. Looks the same. I will get to it. We will do that. So what changed? You didn't mug up really well. So the balance is now 899. We transferred 100. One was a fee. So you have the balance now. And if you see, the nonce has changed. Does anybody want to guess what is that and why does that happen? Yeah, it was 0 before and now it is 1. Can somebody get a mic? And who has the mic?
I think it did incremental transaction. So the previous one was started from 0. So the transaction like it starts from 0 now, and every incremental is now incrementing to 1 plus 1.
So somebody asked, like, what happens if we execute it again? And that's basically the replay attack. If you use an old payload and try to execute again, it should fail. Now in this case, it's a bit wrong. So if I try to execute the exact same payload again, it says transaction is temporarily banned, which is not what you would have expected. It's basically some transaction pool validation where it tries to make sure nobody's trying to DDoS. So if the same transaction is put again, it rejects it. It thinks it's duplicate. But I'll try to do a replay attack. So I think ID will not really work. I think it's the extrinsic. The extrinsic is what the transaction pool looks at. But let's try. Yeah, it's still banned. But what is the replay attack is, I mean, something like that. I'll try to recreate it. So imagine I try to transfer 100 tokens again, or let's say 50 because I want to change the transaction a little bit. But in a real world, like it would be again 100, and this nonce is what protects from a replay attack. So now, when you actually sign the extrinsic, you are signing the nonce with it. So you need to sign the actual correct nonce, otherwise it will give an error. So imagine I gave so current nonce is 0, right? And if current nonce of the account is 1, and let's say I give 3 or 0, okay. It has a bug where it doesn't change by itself. So now current account nonce is 1. I am giving nonce 0. It should hopefully not work.
Isn't like nonce increment by itself every time?
Sorry?
Isn't like nonce increment every time by itself? Like we don't need to manually give it.
No. So whenever a user does a transaction, nonce increases. But when you sign an extrinsic, you sign the current nonce this account has. So that kind of tracks when you did that thing. So imagine if the same payload is done again, it should not again go through, right? It should go through only once. So you encode or sign the nonce itself as well.
Understood.
There is, if you go to substrate bin, and then there is a minimal runtime.
Yeah. So I'm in right now the substrate node template directory, and when I go ahead and run,
No, it's not in substrate node. So substrate node is actually kind of code. It's a part of. It's actually the code resides in Polkadot SDK, and from there you create the node template. But if you go to Polkadot SDK, it has multiple templates. One of them is minimal runtime.
I don't see that. I only see what two directories, one for the node template and one for the front end template.
I could probably show it to you. Or we can do this after the class.
Okay,
If
thank you.
I can show it later. So let me just do it this quickly. So So I'm trying to execute the same transaction with a wrong nonce, and I get transaction is outdated error.
That's cool.
Let's try to do something similar again. Now I will try to give a future nonce. So can I go back? What do you think will happen? I gave a future nonce. Okay. It'll be pending.
I think it will execute.
Yeah, I think you're right. I don't know exactly how much future it can take, but I think Kian will cover in the transaction pool slide lecture. But to some point, I am guessing it would be fine. It would be pending. But if I give it in too much future, then it should probably fail with some error.
Yeah, because of the lifetime.
So it actually does work. So yeah, you're right. But then the balance should not have changed. Or did I do it correctly? No, I'm curious. Okay, yeah. So it's still 899. So the balance didn't change. It's somewhere pending, I guess. But I'm gonna actually try to do it like really in future. And let's try 100 or maybe 1,000 just to be sure. And this. Okay, yeah. Then it goes to pending always.
Change the lifetime of the blocks.
Good point.
Make it maybe
64 blocks.
10, like something 10 or 2, and then we'll see.
How much time? We have 2 minutes. Okay, I'll just do this last thing and hopefully that's. Yeah. Okay. Some error we got. Yeah, I was hoping to get something like, so when you give a old nonce, you should get like a stale error. So this is too old. We got an outdated error. If it's too much in future, you should get something probably like either it goes in pending or it should be like too much in future, right? Yeah.